All right, in this video, we are going to be solving exponential equations. And to do that, we will use the definition of a logarithm and also properties of equality for logarithmic equations and for exponential equations. So the property of equality for a logarithmic equation says if log base b of x is equal to the log base b of y, then x equals y. Now let's look at it in the example. You have log base 2 of x equals log base 2 of 7. Well, think about in the equal sign. What it says is each side has the same value. Well, when it says log base 2 here and log base 2, that is the same on both sides, which means that this and this have to be equal. So x has to equal 7. So we're going to use that property to solve this next example here. It says log base 5 of 4x minus 7 equals log base 5 of x plus 5. So you have log base 5 here and log base 5 here, which means that the 4x minus 7 would have to equal the x plus 5. And my pen is not cooperating here. So we'll just solve that equation to find out what value of x that is true for. So we'd have 3x minus 7 equals 5. And then we have 3x equals 12. And if we divide by 3, x equals 4. So that's the value of x that makes that true. So let's look at that. 4 times 4 is 16. 16 minus 7 would make 9. If we substitute 4 in here, we have 4 plus 5 is 9. So yes, we have log base 5 of 9 equals log base 5 of 9. True statement. So in this next problem, you have log base 3, which means that the 4x minus 6 has to equal the 2x. And then you just solve that equation for x using your regular skills for solving algebraic equations. Now, in this next problem, we have an exponential equation here, 4 to the x equals 11, and we have to solve for x. So one method is to write it in the other form. When it's in exponential form, write it using the definition of log. So we'd write log base 4 of 11. So the exponent on 4 that would give you 11 is equal to x. So log base 4 of 11 equals x. And now on the left side, we have log base 11 of 4. And recently we learned that we can use the change of base formula to evaluate that. Let me grab a calculator here. And to do that, we type in our calculator log 11, parenthesis, and then divided by log of 4. And that gives you 1.73 approximately. And there's your answer. Let's do another one. Again, we have an exponential. We can't solve it this way, and so we're going to write it in log form. So log base 2 of 5 is equal to x. Log base 2 of 5 equals x. And again, we'll use the change of base. So the log of 5 divided by the log of 2. And that is 2.32 is about what x equals. In the next example, we have a little bit more going on here up in the exponent, but we're going to use the same method. We're going to write it using the definition of logs. Log base 7 of 15 is equal to 9x. So again, we'll use the change of base on the left side. Log 15 divided by log 7. And that gives you 1.39, and that equals 9x. And then lastly, to solve for x, we have to divide both sides by 9. And that gives you about 1.155. So that is using the definition. Next, we're going to solve for x, and we're in log form this time. And so we're going to do what's called exponentiate here. And so that's just writing it in an exponential form. So we have log base 4. So we're going to write 4 to the third power equals 5x minus 1. So we're just going to write it in exponential form. So 4 to the third is 64, and that equals 5x minus 1. And then we solve that equation for x. And so x is equal to 13. Let's try it again. Log base 8 of 2x minus 1 equals 1/3. We can't solve it this way, and so we write it in the other form. 8 to the 1/3 is equal to 2x minus 1. And 8 to the 1/3, remember, if we write that in root form, that means the cube root of 8. And the cube root of 8 is 2. And now we are just solving the equation for x. So we're going to add 1 to both sides. So 2x equals 3. And then divide by 2. So x is equal to 3/2. In the next example, it says log of 5x minus 4 equals 3. Now we have to remember that when we don't see a base, it's base 10. So we'll write this in exponential form. 10 to the third equals 5x minus 4. 10 to the third is 1,000. So we add 4 to both sides. So that's 1,004 equals 5x. And then we divide both sides by 5. So x will equal that. And that is about it's a 200.8. All right, next we're going to talk about the property of equality for exponential equations, which says if b to the x equals b to the y, then the x has to equal the y. Well, your bases are the same, so then if you have an equal sign between, the exponent values would have to be the same. So, for example, if you have 3 to the 7th equals 3 to the x, this side would also have to be 3 to the 7th. So x would equal 7. So in this problem, a base of 3, a base of 3, which means the exponents would have to be equal. So the exponent on the left is 3x. The exponent on the right is 2 plus x. So now we solve that equation for x. So let's get all the x's on one side. So we have 2x equals 2. And then divide by 2, x equals 1. So if you plug that back in, 3 times 1 is 3, so this would be 3 to the third. 2 plus 1 is 3, so then that would be 3 to the third. Now, if you'll notice in the next equation, you don't have the same bases. So we can't just set the exponents equal to each other right away. However, if you look at the numbers 2 and 4, 4 could be written with a base of 2. So we're going to leave the left side the way it is. And instead of 4, we're going to write 2 squared because that equals 4. And now you have the same bases. But you already have an exponent up there, and so you have to write it with parentheses around it. So it's 2 to the second times the quantity x plus 1. Now that the bases are the same, set the exponent parts equal, and then you solve the equation. So remember, we'll need to distribute here on the right. And then we just solve. So x is equal to 2. And if we put that back in the original, 3 times 2 is 6. So this is 2 to the 6th. And then this would be 4 to the 2 plus 1 is 3. Well, 4 to the third is 64. And 2 to the 6th also equals 64. So that value of x works when we plug that back in. The next one, you have different bases again. But 27 can be written with a base of 3. So we write that as 3 to the x plus 2. And then instead of 27, you write 3 to the third, but then you also have 2x in the exponent already. And then to solve, you just set the exponents. 3 times 2x is 6x. Set those equal, and 2 would equal, if we subtract 1, 5x. And so x would equal 2/5. All right, in the next problem, there's a few different ways you could do this, but basically we look and we say 4 and 2 are not the same base. But let's just look at the 4 and the 2. We're going to ignore the 1 right now. And the common base that they both have would be 2. So to write 4 with a base of 2, we write 2 squared, and the x is still up there. And over here, to write 1/2 with a base of 2, we have to recall that 2 to the negative 1 is equal to 1 over 2. So this means 1/2, and then you still have x minus 3. So now we set the exponents equal to each other. And then we need to use the distributive property. And then we'll solve for x. So we have to add x to both sides. So we have 3x equals 3, divide by 3, so x is equal to 1. And now we have some other examples, and I want to show you that you could solve these by getting the same base, or we can use the definition of logs. So 16 and 8, if we look at those numbers, those could both be written as bases with bases of 2. 2 to the 4th is equal to 16, and then we have 3x, and 8 is equal to 2 to the 3rd. Now you have the same base, so you just set the exponents equal to each other. 4 times 3x equals 3. So 12x equals 3. So x equals 1/4, which is also equal to 0.25. Now, if we take the same problem and we write it in log form, we would write log base 16 of 8 is equal to 3x. And now on the left side, we'll use the change of base formula. So we'll do log of 8, parenthesis, divided by log of 16. And that gives you 0.75, and that's equal to 3x. And to solve for x, divide by 3. So x is equal to 0.25. So as you can see, you got the same answer using either method. And in these next examples, we're just going to find the common base. So 9 and 27, their common base would be 3. So 9 is 3 squared, and then you have 2x. 27 is 3 cubed, and then you have x minus 1. And so now we set the exponents equal to each other, so that would be 4x equals 3 times the quantity x minus 1. And then you would go ahead and solve that equation for x. Let's look at the next one and just talk about how we would start that problem out. 100 and 1,000, they both have a base of 10. So 100 is 10 squared, and then you have 7x plus 1. 1,000 is 10 to the 3rd, and then you have 3x minus 2. Now, as you're looking at your root sheet, if you have one of those, if you're having trouble figuring out what the base is, you want to look for the line on your sheet that has both of the numbers, and then to find the base, you go all the way over to the left and find which number it is on the left of that column. So here we would set 2 times 7x plus 1 equal to 3 times 3x minus 2. All right, in the next example, we have 81 and 3 that we're going to look at. Well, 81 can be written with a base of 3. That's 3 to the 4th. And then you still have 3 minus x there. 1/3 is 3 to the negative 1. And then you still have 5x minus 6. Now, set those exponents equal to each other and solve. There's a worksheet that goes with this lesson, and I'm going to go through and just do one problem out of each section. So just to kind of review the different ways we've learned. Now here you have a log base 10 and a log base 10. So that means that this has to equal this part. So we set those equal to each other. Now, that equation has an x squared, which means it's quadratic. And the method we use to solve a quadratic is we get everything on one side. So we would have x squared plus 4x, and I'm going to have to add that 2 also. So that would be a negative 45. And on the right side, we just have 0. And to solve a quadratic, we could use a quadratic formula, or we could factor it, and that's usually easier if it's an equation that can be factored. So the factors of 45 are 9 and 5, and 9 minus 5 would give us the 4 in the middle. And then using the zero product property, we set each of those equal to 0, x plus 9. If that equaled 0, x would equal a negative 9. And x minus 5, if that equals 0, x would equal 5. And you always want to plug those values back in to make sure they work. Remember, we can't take the log of a negative number. So if you plug something in and got a negative in the parentheses, it would not work as a solution, and we'd have to cross it out. In the next example here, number 13, we have negative 5 times 10 to the v minus 4 equals negative 20. First thing we're going to do is get the exponential part by itself. So we're going to divide by negative 5 because those are getting multiplied, so we'll do the opposite. So that's 10 to the v minus 4 equals 4. And now we can't solve it in this way, and so we're going to use a definition of logs and write it the other way. So log base 10 of 4 equals v minus 4. Okay, I just used my pattern there. And in the calculator, we can type in the log of 4, which is 0.6, and that equals v minus 4. And then to get v by itself, we'll add 4 to both sides. So we end up with 4.6 equaling v. All right, here's one, number 25. It says log base 7 of 1 over 343. Evaluate it without using a calculator. So when we do this, we want to know what that log is. We set it equal to x, and now we will write it in exponential form. 7 to the x equals 1 over 343. And if we look at our root sheet to see what power of 7 gives us 343, that's 3. 7 to the third is 343. But this is 1 over 343, so x must equal negative 3, because 7 to the negative 3 would equal 1 over 7 to the positive 3, which is 1 over 343. So the value of x has to be a negative 3. All right, lastly, in this next group, now starting with number 33, I would recommend that you write most of these, except for the very last problem on the worksheet, in so that they have the same base. So 2, 16, and 6, they would both have a base of 6 in common. So 2, 16, so 6 to the third is 2, 16. All right, and it also has minus v minus 1 there already. And then 1/6 is 6 to the negative 1. And now, just set your exponents equal to each other. This is equal to this. And then we solve. So distribute. And then divide. So v is equal to negative 2/3. All right, that's it for this lesson. Let me know if you have questions. Thanks for watching.